Welcome back. How are you? Fine. And I'm also fine. Changed little bit. Can you find the change? Change in me. I'm looking now more smart or smarter. Okay, I had a haircut. But the last time we saw that finding change is little difficult. Things happen and then still we don't find change. But thank God that you find change in me. So today we'll do some more stuff, and I can see that still the number is good. And okay, so we'll just start. If you have any questions from last session, if you thought about it, I had uploaded these presentations also. I don't know if you checked them. So if you found anything interesting or if you have any doubt, you can ask. Or if you don't have any doubts, then it's also fine. So today we will start with every time. So we'll start with a question. And this question is interesting. Hopefully we will discuss this question and its answer also in coming days. You can see that there is this red dot. And let's call it A. In some festivities or some places, you must have seen some bulbs arranged in series order. So a lot of bulbs during Christmas time also, lots of bulbs are put together. And if you notice that when the one bulb flashes and the second one and the third one, so like this, you have one A flashing and the another one flashing with a distance. What you actually see is this, a motion, as if light is moving from one dot to another. You do not notice one flash and another flash. Have you seen this thing? In Christmas time, whenever there is this light put, you see light moving from one point to another. Now this is a very normal phenomena. This happens. What we actually see is the motion of light, not two flashes. And if the time is, say, around 80 milliseconds, then you see this movement. So we have two questions. One is that how this happens. When there are only two flashes happening at two different places, how do we see something moving from A to B? And another question is, which is little creepy, is that when A has happened, suppose there is a flash at A, B still has to happen. So there is a flash here and then B has to happen. If you consider T1 in between, middle of these two, you will see this. Now we go back again the previous question. You notice that we have these two also, which is happening before that T2 happens, right? Now the question is that how do we get this one when this has not happened yet? Because T0, one flash, T2, another flash, but at T1, we already see a flash when T2 has not happened yet. It is possible that T1 might happen in this direction, because how do you know that T2 is going to happen there? Now this is a problem of perception, a big problem, that how do we see something which has not yet happened, which will happen in future. So there are two questions again. One is that are we predicting the future? Can we predict the future? We already know that, okay, when there is a flash here, there will be a flash in that direction, not in this direction. So we'll answer these kind of questions, but this is an interesting phenomena that happens every day in our life. So I thought we'll discuss about. Think about this question, how this actually happens. While you think about it, we go into methods. So today's class is all about methods. A small recap from last time. What we have seen so far is that cognitive science is an interdisciplinary study of mind. We take inputs from psychology, neuroscience, linguistics, a lot of things, philosophy. We have also seen that color, shape, movements, touch, etc. are all in our mind. The brain constructs it depending on your experiences. Notion of brain and its function was developed in stages over a period of time. So people thought that brain is nothing but animal spirit, which is there in our head, which allows us to move and do things. But now we have better understanding of the brain and its processes. Just a small idea about brain again. This, does it look good? But this is all that we have. This is all that is creating everything. The brain is, it's a small thing. I don't know if you have ever touched it. I got a chance once to touch it. And it was pulpy. And you can never think that this small stuff is making the entire world that I am seeing. But actually it does. So we have already discussed that left brain is responsible for linear thinking. If you are engineer, then most likely you are thinking from your left side of the brain. But if you are musician, if you are very emotional, artistic, then you are most likely thinking from the right side of your brain. 4 major parts. Frontal lobe, we discussed that it is all about intelligence. Parietal lobe also has the motor cortex. Occipital lobe is responsible for visual, and temporal lobe is responsible for our language in general. Neuron. Okay. So now the fun part begins. I will have again lots of videos, so don't mind. When 2000 years people discussed about brain and animal spirit and other things, and now we have better understanding of brain. But one question that always comes up is that how do we study brain? I have no way of, you know about qualia. Qualia is qualitative experience. Qualitative experience, it means that, okay, what color is this? Black. I see it as black and I call it black. So I have some representation of this black in my head. I cannot be sure that you have the same experience of black which you call black. It is very much possible that you are experiencing it as something what I experience as green, but you call it black. I cannot get, so that is called qualia or qualitative experience, which is very subjective. I have no way of getting into your head and then see the world from your perspective. I have no way. But again, since we want to study brain or mind, there are different ways through which I can try to understand that how in general mind functions or brain functions. So we will discuss some of the methods and I'll discuss some of the experiments that were done. and how they have like shed light on our understanding of the brain. One general video, look at this video.
9, 10.
In almost all of us, language is processed in the left hemisphere.
This is okay. Show me how you can wiggle your fingers. Keep on wiggling.
In this test, in which the patient feels little discomfort, Jun Wada of the University of British Columbia first injects a dye opaque to X-rays into the artery supplying blood to the left hemisphere. This shows the route an anesthetic will follow when it is injected during the test. A similar series of X-rays, seen from above, shows how the dye, and hence the anesthetic, will flow only into the left hemisphere. It is vital the surgeon confirm where speech is located in each patient, so that an intended operation to alleviate epilepsy can be safely performed. The test also shows that the left hemisphere controls the right hand.
Start wiggling.
Okay, so you understand what's happening. What doctor is doing is that the doctor is going to perform some operation on the patient, and he wants to make sure that which part of this patient's language is, or right side or left side. 95% cases it's on the left side of our brain. So when you're speaking, you are using left side of your brain. So if there is a mechanism to somehow anesthetize your left side of the brain, so that only the left side of the brain doesn't work, then you will lose the capacity of speaking and also your motor actions of which side? Right side. Because the left side of the brain controls the motor action of your right side. So this is what they are doing. So this doctor has inserted a dye which can be seen from X-ray, and which is an anesthesia, and he has anesthetized the left side of the brain. So let's continue.
Now I'd like you to count slow and loud to 10 and back to 1.
1,
Don't stop counting.
2, 3, 4, 5, 6, 7, 8.
The left hand remains upright, controlled by the still conscious right hemisphere.
Carry on.
Okay. Carry on counting for us.
Speech gradually returns as the anesthetic clears the left hemisphere.
1.
So what we are trying to do here is to find out which side of the brain, which side these patients have speech function. And these knowledges are very important for us when we are contemplating of operating these patients.
Although 95% of the population has speech in the left hemisphere, there are exceptions. And for this reason, it is necessary to map the geography of each patient's brain to avoid interfering during surgery with such vital functions as speech and short-term memory. In a second test, a week later, the right hemisphere is anesthetized.
Matthew, could you start wiggling your fingers? Keep on wiggling it and look straight ahead. You don't have to look at me. Look straight ahead. Okay? Now start counting loud and slow.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 10, 9, 8.
The conscious left hemisphere.
Okay, so what happened this time is that right side of the hemisphere was anesthetized. So speech was okay, but the left side of the motor actions, they were stopped. Now, these videos are interesting because, they show actually how the brain is actually functioning. Okay, any question?
A group of them were wondering if it's dangerous to do some experiments like that. Dangerous
Yeah,
for
actually,
the patients.
we are not going to do it on you. I also am not authorized to do this kind of stuff. And if I ever ask you, I want to do an experiment like this, don't come. These are normal, experienced doctors. And, there is something called epilepsy. So seizures when you have, there is a very normal procedure that you take some part of your brain out. That's a normal general procedure. So there are people who go through the brain surgery and other things. And I don't know if they are, So this is a procedure actually before actual surgery. So since this was recorded, this we have, just to check. But doctors do it every time. So I don't think that it's very dangerous. But yes, I cannot do it. A medical doctor who is a brain surgeon, neuroscientist, probably will be able to do it. This also gives me a very interesting suggestion. Before coming to Italy, I was working in a place called Korea, South Korea. And they were having a machine called transcranial stimulator, magnetic stimulator. So they call it TMS. Now TMS is a very simple, not bigger than this, and there is a small magnet like this. So what it actually does is that it stops, so you can switch it on and put it some part of your brain. It stops the brain activation, or it can simulate also. So I give a special electricity from outside, and if I know that which part of your brain I have to activate, I can move your fingers. And there, if you ever get a chance, see, there is a documentary, Experience of God. So there is a brain area which is called the brain God area. They call it God area. So there are many people who go to those doctors and then they simulate that part of the brain, and you experience as if you have seen the God or spiritual experience you have. Now anyone who wants to visit or see God, you can find out which part of your brain is responsible for it and then simulate it. But yeah.